So let us start. So do you have any questions from yesterday's class? Any questions? Okay. So yesterday actually we took the simple case, that is finding out the maximum value or minimum value in case of a single variable, independent variable and single dependent variable. Now we will be analyzing today with the help of the partial differentiation to find out the maximum or minimum value in case of multivariable function. To be specific, two independent variable and one dependent variable. That is, if I take the function z is equal to f of x comma y. Now finding out the maximum value in case of two variables. So the thing is, first of all we need to define what is the maximum value. So that is, so maximum value, so in case of normal two-dimensional function, so this is where actually you can find the slope is coming out to be 0. So then we say that the function is having a stationary point there, and there actually the value of the function may be maximum or may be minimum. But here actually if it is a two-dimensional function, definitely f of x comma y will represent a surface. Now that surface may be of this particular a bowl kind of shape. So wherein, if you notice, this is the shape of the bowl. Now this is nothing but the surface area. Now at this particular point, so this function is having minimum value. So this function is having the minimum value at the bottom of this particular bowl. Suppose if this bowl is inverted, then this is the kind of shape it is going to be. And this shape, exactly at this particular point, this is having the maximum value. Now this is represented by the function z is equal to f of x comma y. So this is also represented by the function z is equal to f of x comma y. Now this is the shape of bowl, so that means this is the surface. So it's not a single line. Now how do we define the maximum point? That is, if you take any surrounding point from there which is at a distance of h comma k. So from the point f of a comma b, if you take a point, nearby point, for a distance of a plus h from this and a plus b plus k from this, that means the xy locations are shifted by a distance of h comma k. That means this position is a plus h comma a b plus k. Now if you take the function value from the bottom, so let us say this function value is f of a comma b, and this function value will be f of a plus h comma b plus k. Now if you take the difference between these two, that is f of a plus h comma b plus k minus f of a comma b value, for a maximum value, should it be positive or negative? For a maximum value, is it positive or negative? It should be negative. Why? Because see this, a plus h and b plus k should be definitely less than the value of a comma b, right? If you take the difference between this and this, so from this you are subtracting a maximum value. That's why you will get negative. Got it, Ravindra? Now for the minimum value, so if you take this particular point, so this point I'll just draw it here, a bigger shape. Now for this particular shape, so if you take the xy axis and this point, so is nothing but f of a comma b, and then any nearby point surrounding that, so this is h comma k, so this is a plus h comma b plus k point, then this function value will be f of a plus h comma b plus k. Now if you take the difference between f of a plus h comma b plus k minus f of a comma b, and this value definitely should be greater than 0, then only we say that f of a comma b is having the minimum value at the point a comma b. So this is the point of minimum value. and this is the point of maximum value, and it is occurred at a comma b, and the maximum value is f of a comma b. So maximum value will be is f of a comma b and occurs at point a comma b. So here also the minimum value in this case, so minimum value will be f of a comma b and occurs at a comma b. Got it? So this is how you will find the maximum value or minimum value. So this is how you will identify. Now this is the function which is responsible for all the conditions of the maximum value or minimum value. So this function, if it is less than 0, it is maximum value. If it is more than 0, then it will be a minimum value. Now actually we will identify the corresponding conditions with the help of partial differentiation to identify the maximum value or the minimum value in case of a two-dimensional variable. So sorry, two variables. Got it? So note down this. Now we'll see the conditions of the maximum value or minimum value. Those conditions are, so f of a plus h comma b plus k. Now we will expand this with the help of Taylor's expansion. So this Taylor's expansion will be, so f of a comma b plus h into dou f by dou x plus k into dou f by dou y plus h square by h square into dou square f by dou x square plus 2h k into dou square f by dou x dou y plus k square into dou square f by dou y square plus dash 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 up to infinite. And then this is the expansion of Taylor's expansion of this particular function, right? So this Taylor's expansion is responsible for deriving all the conditions. So now if you take the difference, that is f of a plus h comma b plus k minus f of a comma b, and this value is coming out to be h dou f by dou x plus k dou f by dou y plus h square into dou square f by dou x square plus 2hk into dou square f by dou x dou y plus k square into dou square f by dou y square. Now neglect the higher order terms. Neglect the higher order terms, as h square k square will be negligible. Negligible if you take further higher. Higher powers, as h tends to 0, k tends to 0. So nearby points one we will be considering, right? So h will be tending to 0 and k will also be tending to 0. So if that is the case, obviously h square, considering h square itself is most reasonable. So if you consider further, right, so accuracy increase will be very, very less. 0.001% the accuracy will be increased, but the complexity will be 99%, it will increase the complexity. So that's why we will neglect all the higher order terms and we will keep only to the second order term. Now here, this is the difference. Now this is nothing but the delta for us. So the sign of this delta is responsible to have a maximum value or minimum value. So if this delta is positive, it's the minimum value. If this delta is negative, then it will be the maximum value, right? So keeping that understanding, now you have to derive the conditions. See this here, suppose if you take this part, so in this particular part, let us say if k equal to 0, let us say because actually h and k are actually you have the flexibility to select your own values. Let us see if k is equal to 0, then it is dependent on h, right? So dou f by dou x is one value if you have it, then depending upon this h value, so this is going to be changing. That means if you take a positive h, you are going to get the positive value. If you get negative value for h, then you are going to get the negative value. That means this is deciding this sign. That means if this is present, then automatically you will not be able to identify whether the function is maximum or minimum. So you have to avoid this h. How can I avoid that? By making this value 0. Got it or not? Understood or not? For a randomly selected value of k, h is making the changes for the sign. Now if I make h independent, then I can make dou f by dou x is equal to 0, so that I can make h is independent, so that my sign is not going to be decided by the random selection of h value what I have selected now. Exactly in the similar manner, if I make h is equal to 0, then correspondingly this k value will exactly the same functionality as that of h. That means this k will decide my sign of delta. So I wanted to make independent of this k for this delta. So that's exactly the reason why we did dou f by dou x is equal to 0 and dou f by dou y is equal to 0. So this is the fundamental condition which we are going to check it, so that this h and k selection will not make changes to this sign. Got it or not? Understood? So finally, I wanted to make my selection of hk value is independent of this sign, so that this sign actually deciding whether the function is having maximum value or minimum value. So that if it is dependent on my selection, then there is no meaning for this sign. So that's why I have to make it independent with these two conditions. So this is the first conditions, and then we'll go to the next conditions. The next conditions are, let us say I call this r is equal to dou square f by dou x square, s is equal to dou square f by dou x dou y, and t equal to dou square f by dou y square. Now if I make these two 0, then delta is dependent on only the functions h square r plus 2hk s plus k square t. Now this is the one actually which will decide the function. Got it? Now I wanted to make this also independent. For that, what I will do is I will multiply with r and divide with r, so that this is h square r square plus 2hkrs plus k square rt. Got it? Now this one 1 by r times of, so h square r square 2hkr into s, k square rt is there. Now here what I will do is hr whole square plus 2 times of hr into k into s. Yeah, 2 into hr into k into s plus k square rt. Now actually this we will further divide, so that actually I wanted to make the independent of hk. Yeah. So where is the doubt? So once you understood this one, what I wanted to make it, here it is h square r plus 2hk into s plus k square t. So where r is equal to dou square f by, so where r is equal to dou square f by dou x square, and s is equal to dou square f by dou x dou y, and t is equal to dou square f by dou y square. So this equation I have written in this particular format by giving corresponding variables rather than writing every time dou square f by dou x square or dou square f by dou x dou y like that. Now there actually I have replaced with r, s and t. Rest of the things is as it is, whatever is kept it here. Now here for this actually what I have done is, so anyway I have made independent of this part. So hk are not responsible now, but hk are involved here also. So here also I wanted to make independent of hk. For that what I have done is, so once I remove this after substituting 0 0, then I have got the equation h square r plus 2hk s plus k square t. Now for this actually I wanted to assure that it is independent of that. For that, the methodology whatever I have adopted is the square of any negative or positive value is always a positive number. So that's why I wanted to make some squares in this so that I can make everything is positive. And then I'll try to make dependent on only the variables like R, ST and is independent of HK because HK are the selected values by me. So which should not make the sign of this delta. So for that, I have made that I have divided with R and then multiplied with R so that I can write as a square of this HR plus something. Got it? Understood? Surabhi? Okay. Now actually note down till this point. Now I am going to erase it and rewrite it. Done? Okay. Now here what we have got is delta value is coming out to be 1 by R times of HR whole square plus 2 times of HR into KS plus K square RT. And this is 1 by R times of HR plus KS whole square minus KS whole square plus K square RT. And this is 1 by R times of HR plus KS whole square minus K square or plus K square RT minus S square. Got it? Understood? Now here, if you notice, here actually HR plus KS whole square always a positive number. So this is always a positive number. And this K square is also a positive number. Now this RT minus S square, so this will decide the sign, right? Here it is anyway independent of H comma K. So this is now RT and S values are deciding the sign of this delta. So this delta sign is getting decided by this. Now if this is positive, then actually I can think of R is the only responsible component in this. So for that, what I will do is RT minus S square, I will make it 0. So this is positive. Then only responsible variable for delta will be R. So this R will decide now. So my conditions are, one is dou f by dou x equal to 0, dou f by dou y is equal to 0, and RT minus S square should be greater than 0. And another condition is R value will decide. Now if R is negative, then will it, so what do we get, positive or negative? If R is negative. So everything is positive here except for R. If R is negative, delta will be negative, right? If delta is negative, are we getting the positive value in negative? I am expecting answer from you. So delta value is deciding the maximum value or minimum value. Now delta is dependent on only R because the rest of the value is anyway positive. So R is only the responsible component. If R is negative, then delta value will be negative. If delta value is negative, are we getting maximum value or minimum value? Obviously maximum. So if R greater than, so R less than 0, maximum value, R greater than 0, minimum value you are going to get it. So these are the conditions for finding out the maximum value or minimum value in the case of two variables. Got it? So dou f by dou x you have to equate to 0 and dou f by dou y you have to equate to 0. Rt minus s square you have to assure that it is greater than 0. Then r is the only responsible component. If r is less than 0, then you are going to get the maximum value. If r is greater than 0, you are going to get the minimum value. But what if rt minus s square is equal to 0? Then that case rt minus s square, if it is equal to 0, so this is further investigation is needed. Got it? Because actually we cannot assure whether it is a maximum value or minimum value, because we treated here it is rt minus s square as positive, and based on this condition we have derived all the formulas. But if this is negative, if this is negative, anyway it is ruled out. If this is negative, we cannot say it's a maximum value or minimum value. But if it is equal to 0, then actually we have to further investigate whether you are going to get a maximum value or minimum value. Got it? You can note down this. So these are the conditions actually we have to assure. Clear? Okay. Now based on this understanding, we'll solve some problems. Examine the following function for extreme values. For extreme values, the function is x power 4 plus y power 4 f of x comma y is equal to x power 4 plus y power 4 minus 2x square plus 4xy minus 2y square, and this is the function minus 2x square plus 4xy minus 2y square. Now examine the extreme values for this. So the first thing is you have to equate dou f by dou x equal to 0, and another condition is dou f by dou y is equal to 0. Then you have to find out rt minus s square value. So this has to be equated to greater than 0. Then actually based on these conditions, we will try to check whether you are going to get the maximum value or minimum value at the corresponding values. Now we'll see. So what is dou f by dou x? This is 4x cube minus 4x plus 4y, and this is equal to 0. It implies x cube minus x plus y equal to 0. And then dou f by dou y also is equal to 0. That is 4y cube plus 4x minus 4y. This is equal to 0. Then this is y cube plus x minus y equal to 0. Now if you add these two equations together, this is equation number 1 and this is equation number 2. If you add these two together, then x will cancel and y will cancel. X cube plus y cube equal to 0, or x cube is equal to minus y cube, or x cube is equal to minus y whole cube, because minus 1 whole cube is anyway minus 1. So x is equal to minus y, and this is the condition. So if I equate x is equal to minus y in any one of the equation, then x cube minus x minus y minus x is equal to 0. So plus y will become minus x. Then x cube minus 2x equal to 0. It implies x into x square minus 2 equal to 0. It implies x is equal to 0 and x square is equal to 2. It implies x is equal to plus or minus root 2. So as x is equal to minus y, the points are x comma y is equal to 0 comma 0 is one point, and then root 2 comma minus root 2 is another point, minus root 2 comma root 2 is another point. So these are the three different points. Got it? So these three different points actually we have to check so you have to check for the maximum or minimum or saddle points. So maximum point or minimum point, saddle point is where you cannot find out maximum or minimum value, but still those are solutions of this equation. So being the solutions of these equations, that will not assure for us to have a maximum value or minimum value at that particular point. So because the further conditions also needs to be tallied. So here we have got three different solutions. So out of these three solutions, some points may be maximum, some may be minimum, some may be not maximum, not minimum. Got it? Okay. Now actually it is up to you. How do you want to check this? Now find out dou square f by dou x square, which is nothing but r. R is equal to dou square f by dou x square, and t is equal to dou square f by dou y square, and s is equal to dou square f by dou x dou y. Find out these values at these points, and then make sure whether these are positive or negative. Got it? Yeah. R greater than 0, but rt minus s square. What is this value? Now I hope you noted down this. So it implies dou square f by dou x square 12x square minus 4, and dou square f by dou y square, then this is 12y square minus 4, and dou square f by dou x dou y, this is 4, and this is also 4. Yeah, 4. Got it? So rt minus s square is coming out to be rt minus s square. Now this value will take case by case. Case 1. So root 2 comma minus root 2. Now rt minus s square for this one, is it positive or negative? Root 2 comma minus root 2. So you can substitute the values root 2 comma minus root 2 in this equation. So you are going to get, yeah. So this is a positive value. And then in case 1, rt minus s square is greater than 0. And what is the value of r? R value greater than 0 or less than 0? Is it positive or negative? R value. So this is positive. So if this is positive, are we getting maximum value or minimum value there? So it is minimum value. And then case 2. This is minus root 2 comma root 2. Now rt minus s square, I think it is positive only. And r value, is it less than 0 or greater than 0? Rt minus s square, is it positive or negative? For case 2, that is minus 2 comma root 2. Minus root 2 comma root 2. So rt minus s square is positive, and then r is also positive. So we are going to get maximum value. So r is less than 0. So you are going to get maximum value, I think. So Ravi, it should be maximum value, I think. So r is less than 0 in this case. Minus root 2 and root 2. Is it less than 0 or greater than 0? Minus root 2 and root 2? Positive only. Okay. So if it is positive, then still you get minimum value only in both the cases, I think. Got it? Okay. And then what if case 3? That is 0, 0. So what happens with RT minus S square? But RT minus S square is 0, right? Then R will not decide. So if RT minus S square is 0, then you cannot decide. This R value can be maximum or minimum, right? So it needs further investigation. What is that further investigation now? How can we conclude whether there is a maximum or minimum value there? So that is at 0, 0. Now we take one case, that is the function value is f of x comma y is nothing but the function value f of 0, 0. So what is this value? This is coming out to be 0. Now we will take one case along x-axis. That means, suppose let us say this function is like this. Now this is x-axis and this is, so this is on the plane. So this is y-axis. Now along x-axis if you take it, that is y is equal to 0. On this function, if you try to approach the value along x-axis, that means keeping y is equal to 0 in the equation, this value will be f of x comma 0. So x power 4 minus 2x square. So this is the value. Now if you notice, whatever may be the value of x, so nearby value if you take it, any nearby value, x is equal to 0.1, let us say. So x is equal to 0.1, it will assure that 0.1 whole power 4 minus 2 times of 0.1 square. This will be definitely less than 0. Correct or not? Understood or not? This value is less than 0. Now actually you take one more line, maybe somewhere in between x is equal to y line. So x is equal to y line, if you take it in this f of x comma x, because x is equal to y. Now in this equation, x power 4 plus x power 4 minus 2x square plus 4x square minus 2x square. So this value is coming out to be, so 2x power 4 minus 2x square plus 4x square. Now take this one. This value, whatever may be the value of x, in and around x is equal to 0 and y is equal to 0, this is always a positive number. So this is a less than 0 and this is a greater than 0. So for a maximum value at one particular point, can it have a negative value and positive value for the same function? Got it or not? So it can be extreme only if both are positive or both are negative, correct or not? So the curve has to be either like this or like this, but it cannot be like this. Got it or not? So at this particular point, if you notice, this is negative value and this is positive value. So this side is positive and this side is negative. So obviously at this particular point, this is taking turn like this, tangent may be 0, horizontal, but it is not an extreme value, correct or not? So this is the key rule actually we will identify to assure that either it is not an extreme value, got it or not? So if it has to be an extreme value, both the values in and around, whatever may be the values of h comma k you selected, both has to be positive or both has to be negative. Then only we say that it is an extreme value. But in this particular case, if you are able to prove that at least one case for any value of x comma y nearby that is 0 comma 0 is the point where we are checking. So delta x tending to 0 and delta y tending to 0, for any value, if you are able to prove that one is positive and one is negative, then you can conclude that this is a saddle point. This is a saddle point because One value is negative, we proved, and one value is positive, we proved. Limit delta x tending to 0. Got it? So in and around nearby 0, 0, you select any, let us say 0.1, this is a positive number. You select 0.1, this is a negative number. Clear? But along different paths at 0, 0. So this is along y-axis, this is along x is equal to y line. Do you have any questions on this? Any questions? Note down one more. Discuss the maxima and minima of the maxima and minima of f of x comma y is equal to x cube y square x cube y square 1 minus x minus y. This is the function. Can you check the extreme values for this first? So exactly the same procedure, dou f by dou x equal to 0, dou f by dou y equal to 0, find out r value, s value and t value, and then ensure rt minus s square is greater than 0 or not. If it is greater than 0, then correspondingly find out r value. So for those points, whatever we got it based on these two relations. Got it? So can you check it now? What are the values? You tell me the points first. Tell me the extreme points. So take the derivatives and equate to 0 and solve these two equations for that. 0, 0 is one value. What is the other value? 1 by 2, 1 by 3. Yeah, correct. 1 by 2, 1 by 3. Not 1 by 3, 1 by 2. The order should be different. Yeah. Okay. So 0, 0 is one point. And 1 by 2, 1 by 3 is another point. Now at 1 by 2, 1 by 3, first you check it. So are you getting the maximum value or minimum value? For that, rt minus s square should be greater than 0. First you assure this. Then the r value. So r value is positive or negative? So it is negative. R value is negative and rt minus s square is positive. So you can get maximum value at 1 by 2, 1 by 3. Now what is the value of maximum? What is the maximum value? Substitute 1 by 2, 1 by 3 in the original function, we are going to get the maximum value. So what is that value? Substitute this point here. So f max of 1 by 2, 1 by 3 will be how much? So this is 1 by 432. Check it. 1 by 432. Now check the other condition. That is for 0, 0. Now what is happening with rt minus s square? Is it positive or negative or 0? rt minus s square. Yeah, 1 by 432 is correct. So what is rt minus s square for 0, 0? So it is coming out to be 0. Then we need further investigation whether it is a saddle point or not. right? So it may be a positive, it may be a maximum value, or it may be a minimum value, or it may be a saddle point, which we don't know. Now to assure that, what we will do is, we take some path around 0, 0, because we are trying to find near 0, 0, and then try to approach this particular function, that is f of x comma y is equal to x cube y square into 1 minus x minus y. Now here, along y is equal to x, path if you take it, f of x comma y is equal to, so this is x power 5 into 1 minus 2x. So along y is equal to x. So along y is equal to x, x power 5 into 1 minus 2x. Now we take two different values. Suppose if x is equal to 0.1, then 0.1 whole power 5, 1 minus 2 into 0.1. So 1 minus 2 into 0.1 will be positive value. Got it? Now what if, so this is f of x comma y value is greater than 0 in case if x is equal to 0.1. If x is equal to minus 0.1, then f of x comma y minus 0.1 whole power 5 will be a negative value, and then 1 minus 2 times of minus 0.1 is a positive value. The product of these two will be a negative value. So one value is positive and another value is negative. So if that is the case, it will be definitely a saddle point. So 0, 0 is a saddle point. Neither maximum nor minimum there. Got it? Neither maximum nor minimum. Got it? Any questions? Any questions on this? Okay. So note down one last problem. You take this as homework and solve it. In a plane triangle, find the maximum value of cos A, cos B, cos C. Cos A, cos B, cos C, you have to find out the maximum value of the product of cos A, cos B, cos C. So this you take as homework. In case if you are not able to solve, then I am going to solve it in the next class on Monday. Got it? Any questions? Okay, yeah. So that's all for today. Yeah, thank you. Good night.